Hello friends, today's video is just the extension of my previous video where I explained what is lens and different types of lenses and also the terms associated with a lens. In this video, today I am going to discuss about the formation of image by a lens. You know that the position, nature and size of the image of an object formed by lens can be determined by drawing the ray diagram. So before drawing the ray diagram, I would like to say about some principal rays for ray diagrams. That means nature of the certain light rays after the refraction. That means how the rays or light ray behave after the refraction. You know that to get the image of point of an object, suppose this is the point, I want the image of this point. So definitely from this point I have to take at least two rays. The number of rays comes from this point object in all possible directions, but to get the ray diagram at least I have to draw two incident ray from this point object. So for that purposes, I should know the different types of rays for ray diagram. What are the different types of rays for ray diagram? Especially some principal rays, some important rays. Let us see. This is the biconvex lens. You think that this is a very thin lens. This is the plane of the lens. Okay. Now, this line represents the principal axis. This is the optic center. It is the biconvex lens. So, the first focal point is f1. Here is the second focal point f2. You can take it at equal distance from optic center. So, suppose one light ray incident at the optic center. After incident, it refracts without changing the direction. This is the case of a biconvex lens. If it is the case of a biconcave lens, see that this is the plane of the lens, principal axis. This side I can write f2, the second focal point. This is the first focal point. Okay, this plane and principal axis exactly perpendicular. Okay, so in case of a biconcave lens, if the light ray incident at the optic center, then it refracts without changing the direction. So I can say that the light ray which incident at the optic center, okay, refract without changing the direction. This is the case of a biconvex lens. Same thing happen also in case of the biconcave lens. Okay. First ray I have taken through the optic center. Next point. Second point, see, this is the biconvex lens with the principal axis. This is the plane of the lens. So this point is F1, first focal point, second focal point. Now, if the light ray comes close and parallel to the principal axis after incident here, it passes through the F2. If it comes parallel, it passes through the F2 in case of a biconvex lens. If it is biconcave lens, means concave lens, this side is F2, this side is equal distance both F1. So, if it comes parallel to the principal axis, it refracts in such a manner. However, it is coming from the focus. So I can say that in this case, the light ray which comes parallel to the principal axis after refraction passes through F2 through this focus. In this case, what happens? The light ray which comes parallel to the principal axis refract in such a manner it appears. So the light ray which comes parallel to the principal axis refract in such a manner, however it appears coming from F2, coming from the focus. This is the second ray. Third case. This is just like similarities with the concave mirror in reflection topics. Third case. This is the biconvex lens, plane of the lens. This is the principal axis. This is F1, first focal point, second focal point. Okay? Now you see that the ray which comes through the focus after refraction, it moves parallel to the principal axis. Similarly, in case of this biconcave lens, the lens is here very thin. So here is F2, here is F1. So it is coming through the F1. This side I have taken F2, this is F1. So the ray which comes towards the F1, it moves parallel to the principal axis. Here also going through the F1. After refraction moves parallel. It is coming towards the F1. So it refract, however, refract parallel to the principal axis. So I can say that the light ray which comes through F1 after refraction moves parallel to the principal axis. In this case, the ray which comes towards F1 after refraction moves parallel to the principal axis. So this is about some of the important light rays, how they behave after refraction. These rays will help us to draw the ray diagram. We know that there are two types of images we find here. What are the two types of images? One is the real image, second one is the virtual image. Real image is formed when two light rays, at least two rays, meet really. And virtual image is formed when the two light rays, after refraction, they appear diverging from a common point. Or you can say that if the refracted rays produced, they meet at a point. In that case, we get the virtual image.